for recording. Alrighty. Well, thank you for coming. I am going to be talking about how to engineer for security compliance, and that doesn't just mean we're talking about code. This is not going to be a checklist on, do these specific things and you will pass your compliance. It's all about setting up a process, a pipeline, toolings, best practices that will have you be prepared when the time comes. For those of you that don't know me, I'm Matthew Connerton. I'm the VP of Software Development and Engineering at Encore Healthcare, and I've been playing with Drupal around 17, 18 years now. Encore Healthcare is a software developer and population health company that focuses on providing better outcomes for patients with COPD and chronic respiratory diseases while reducing healthcare costs for the healthcare systems and the payers. So what I want to do is just clarify a few things we're going to be talking about. SOC 2 is a framework that was developed by the American Institute of Certified Public Accountants to evaluate how service providers manage customer data across 5 trusted sources: security, availability, process integrity, confidentiality, and privacy. There's 2 types of SOC compliance. Type 1 is just a point-in-time audit, and it's a self-service audit. You just run it yourself and submit it, and it's a point in time saying, do you have the controls designed correctly today? And then type 2 is a period audit that says, did you actually implement those controls over time? HITRUST is a comprehensive prescriptive security and privacy framework around healthcare regulations, HIPAA, high-tech, ISO, PCI. You can think of HITRUST as SOC 2 on hard mode. For us, it was one that our company was decided to implement because one of our customers needed us to do it. We were actually pretty small. We're on the small side of a company to have implemented this. We only have 50 employees, so we're pretty proud that we were able to get through this. How this all fits together, SOC 2 and Type 2 are the, assurance of our security policies, and then HITRUST is a comprehensive set of rules on top of it that also apply to healthcare and PHI. This is not something that's one and done. Once you get compliance with SOC 2, Type 2, HITRUST, these types of certifications, you're going to do it forever. It's an annual process. Now, the first part is pretty intense, but after that, the annual review is just reviewing a set of the core things that you need to follow. There are other frameworks you might be familiar with: the HIPAA framework, PCI, FedRAMP. These are all different types of security frameworks. All right, and then I also want to talk about what we were actually securing on our end. We have an application called Nexus, which is a portal for our respiratory therapists to manage patients and their assessments and their ventilators and make sure they are staying compliant on those ventilators. It's a multi-tenant clinical SaaS platform. It's fully decoupled. We have a front end on React in AWS, a back end on Drupal 7 on EC2 server. We're using AWS databases, private files in S3. It's all AWS, VPCs, IMA roles, what you would typically expect to find in AWS. But everything I'm going to talk about today applies to any of the major cloud providers. It applies if you're hosting your stuff on Linode or DigitalOcean. What was actually in scope versus out of scope was pretty important. Our in scope was our production infrastructure only. Anything that had production code on it that was running production data with production customers. So our CloudFront, our Lambdas, our servers, our VPCs, the subnets, the security groups, the application firewalls, anything that connected PHI to the customer was in scope. And that's our front end, our back end, and then we have a couple of other helper servers here and there. Also in scope for us were our employee laptops and workstations and anybody that had their own phone because they're accessing company emails that may have PII or PHI in it. and any privileged user, specifically in any of those environments, were in scope as well. What was not in scope was basically everything else. Our non-production environments on a utility server, that wasn't in scope. Now, you still want to keep that stuff secure, obviously, but it wasn't included as part of the hard requirements here. We have one corporate office in Tennessee. That wasn't in scope because we don't actually store, servers in that office. The laptops and computers there were in scope, but the office as a whole was not in scope. If an office was in scope, you need things like security access through the doors and a way to audit who's coming in and out, locked server rooms with their own access controls, stuff like that. Our internal business applications were not in scope if they weren't directly used for customer data. Some of this stuff does kind of fall in scope, but some falls out of scope. Our email technically was in scope because we run everything through Google, and that was a production system, so that was in scope. Slack, we have enterprise with the BAA with them, so that technically was in scope, but we don't use Teams. None of the other stuff was in scope either. None of our customer devices or environments are in scope. That's their responsibility. And then any of the non-prod utilities, the test runners, pipelines, anything like that wasn't directly tied to production was also not in scope. So let's look at the process. It is quite a journey. I'm going to specifically be talking about HITRUST, but it all applies to SOC 2 and some of these other frameworks as well. We took a readiness assessment in the beginning, which is kind of like type 1, SOC 2, type 1, and that was 25 requests. They said, prove that you're doing these 25 things. And we said, oh man, this is easy, and we did it. And then they said, okay, let's actually do it. And it was 348 requests that we then had to prove everything we were doing across the different security controls. We partnered with a security compliance partner called Thoropass. When you guys get serious about doing this, unless you hire someone dedicated to focus on this, you have to have a partner like this to be your auditor and guide you through the process. You want to communicate with them early when it comes to these requests, because some of them are incredibly abstract and make no sense. So you have to say to them, hey, what does this actually mean for our environment? Because it means something different for everybody else. Clarify the ambiguous ones and ask them, what are you looking for here? What evidence do you want that's going to pass this control? For HITRUST, you got to plan for 1 to 2 years to go through the entire process to finish this and get that certification. Just to prepare and do the scoping, understand the requirements is 2 to 4 weeks. Taking that readiness assessment, that 54 controls, that was 2 to 3 months for us. The remediation and evidence collection, so if we didn't have everything ready for those 54 controls, we had to fix it and tweak it, and then go through evidence collection. That is 6 months to a year, and then for them to validate it at the end is going to take them 4 to 8 weeks, and then for the actual HITRUST organization that certifies it, that was an additional 6 to 12 weeks. So for how long this is going to take you, if you're already done your SOC 2 Type 1, you got good best practices for your security disciplines right now, you could do this in 9 to 12 months. If you're a typical SaaS organization that has some gaps in your security, maybe you're looking at 1.5 years. That's where we were. I think we got it done in like 16 months total. And we did SOC 2 and HITRUST essentially at the same time. We did our SOC 2, and then when that was complete, immediately went into HITRUST. There were a lot of overlapping controls that we were able to reuse the evidence or the techniques to get that evidence. If you're brand new to this and you haven't really set up any of the controls or the best practices, you're looking at 1.5 to 2 years to get this through. Some of the timeline delays you're going to find is evidence that wasn't gathered during the period that it was required for. So they are going to say, we want to see your controls between this, these 90-day period. And you have to prove between that 90-day period that you did the things you said you were going to do. If you were supposed to have a pen test during that time and it was before or after, that doesn't count. You can't pass that control. If you have vendors, a BAA is a business associate agreement. It just says that in the healthcare industry, you're going to protect my data, I'm going to protect your data, we're going to protect each other's healthcare data. We didn't have one for one of the vendors and had to scramble and get that going pretty quick. If you don't have disaster recovery or business continuity testing happening, you got to make sure that's going on. Change management, we'll talk about all this stuff. Basically everything we're going to talk about, if you're not doing it, that's the type of stuff that will delay it. Find a consultant. Like I said, we use ThoroPass. They don't have an affiliate program or anything, but they were really helpful in getting us through these two certification processes. All right, that's the 11-minute preamble. Now let's actually talk about what we have to do. The number one important thing you can do to prepare for security audits is document everything you do all the time. It is the most important principle. I think 60 plus of the change requests and controls were all about that we were documenting the things that we're doing. Any change request, any deployment, any upgrade to infrastructure, any decision that's being made has to be documented somewhere, somehow. If it's not documented, you can't prove that you did it. If I'm giving a senior dev access to the production environment and I just go in and give it to them, later when I have to prove that we have, someone requested access and he was approved access and then given access, if that's not documented anywhere, then that's going to get us flagged because, Ben has access to prod and I can't prove why he has access to it. So you need to just document everything all the time. All decisions, all changes need to go through a documented approval. Someone requests it, someone approves it. You need at least two people in that chain. You want to store the documentation in the central auditable repository. It really doesn't matter what it is. It doesn't have to be some big fancy Confluence wiki. It can be a bunch of Google Docs in a Google Drive. It can be a spreadsheet. It can be Jira. It can be any project management tool. Just whatever it is that you pick, stick to it and be consistent with it so that you just have that consistency from start to finish. You can even document in your code base. That's something we do with a lot of our documentation, is put it in our docs folder for like our architectural decisions and stuff like that. So I say document everything. What specifically are we looking to document? Well, this presentation will talk about all the things that we're doing, and you have to document those. The software development life cycle, about how tickets go from being created to being implemented. That needs to be documented all the way through. That's just your ticket system. Any sysops and DevOps changes. You need a new server, you want to add memcache, you're going to decide to use Postgres for something. You need to document that you're doing it, and then you can actually do it. Architecture decisions. We're deciding, we're not going to use Redis, and we are going to use, whatever. And we made that decision here, and that's why, and these are the rules. The biggest tip here is start as early as possible. Start tomorrow, start today. Documenting everything you can, build it into the culture of what you do. Leverage AI. Especially when it comes to tickets, I have AI tooling now that I put in, and it helps me with my requirements and finds edge cases and business requirements, and then we take that and turn it into specifications, and then I turn it into Jira tickets. AI can be really helpful here. Go ahead and start leveraging that. So from the business side of things, a big part of the documentation is your policies and procedures. So you have all these rules, you have to write down those rules. No junior devs or no one's allowed to just have SSH access to prod, not just because someone said so, because it's in our policy and procedure that nobody's allowed to have that access. And if they want that access, this is how they get that access. Start with templates. Just Google policy and procedures for SOC 2 Type 2. If you're going with a consultant partner, they're going to give you a bunch of templates. Find that central place to put them and put them there. And you will then have to review those templates every quarter, twice yearly, whatever it is. You have to make sure that you're reviewing them in a pretty frequent manner. There are a lot of policies and procedures that you need to have documented. Here are 24 of ours. I think we have less than 30, but these are basically the standard ones that you're going to need across security, operations, privacy, and governance. And all of these procedures and policies are going to dictate everything else. These are the rules that you defined, and now you need to follow them. And SOC 2, Type 2, and HITRUST are going to say, do you have a policy for this? All right, do you have a procedure for this? All right, show me that you followed that policy and procedure during the time between June 1st and August 1st. And you need to show them evidence of all three of those things. So after you've documented everything, the next step is to log everything across all your systems. Because if you're not logging it, there's no record that it happened. When you're logging your stuff, the context of what is happening is very important, especially for a SaaS platform, especially if it's a multi-tenancy SaaS platform. All of our logs have context for the account in the organization, the identity of the users and roles of the thing that happened, trace IDs that span across different systems. When it comes to compliance, you cannot overlog, but you can certainly underlog. And the more context you can add into those logs, the better. For your log storage, if you're starting out small, put it in the database. Again, you don't need to get super fancy. When you graduate from your DB log, you're going to find an aggregate, location to put them. That could be, like an Elk Stack. It could be a New Relic, a Datadog somewhere else. If you're not dealing with PHI or PII, those are fantastic locations. If you are dealing with PHI and PII, then you probably want to do it in, your own system. AWS has OpenSearch for dirt cheap, and you just shoot logs there. And they have, a built-in OpenSearch dashboard that you can search for them and have access to them. We use Datadog because they help with a lot of the other security compliance requirements we have. But we're not actually pushing any PHI to Datadog. They're doing the bulk of our logging, but we also are working on pushing a separate set of logging that does contain PHI to our own OpenSearch infrastructure. We're talking about Drupal. Monolog is a great module here that will take your logging channels, and you can say, send the logs instead of database, put them to a JSON file, and then that can be aggregated somewhere else, or send them directly here, or split them so that these ones go here and those ones go there. Monolog is a great one for helping manage all those logs. Log retention is very important. Not only do you need to log it, but you got to hold on to those logs for a while. SOC 2, I think, is at least a year. For HITRUST and HIPAA requirements, we have 6 years of auditable log requirements. So we keep those logs, we hit them, put them in cold storage in S3 when I think after 90 days or something like that, maybe a year, is when they transition over to that. What are we going to log? You want to log all the standard Drupal log stuff. Anytime configuration changes, make sure that gets logged. If you have automated jobs or background processes, queue workers, Symphony Messenger, things happening in the background, make sure that's logging, that it's doing something. Anything that's security related, if someone gets a role, if someone gets approved, blocked, registered, all of those user events in Drupal, you want to log. Some of that happens automatically, some of them you need to contrib for, some of them you just need to implement yourself. We use revisions for logs a lot. For our patient data, we don't delete anything. Everything gets revisioned forever. So we can use the revisions themselves, our logs. Anytime a patient changes, if they say, well, why is this happening with this patient? Well, I can go back and say, on January 13th, so-and-so changed the patient, and that's why it looks like that. So revisions count as logs. In AWS, you have CloudWatch, which is watching over the infrastructure itself, the users, the admins. You have CloudTrail. I'm sorry, that's opposite. CloudWatch is doing all the logging stuff. CloudTrail is watching all the auditable events in AWS. And then we have GuardDuty that does like the anomaly detection and saying, hey, something weird's happening there. You can have logging outside of traditional logs. We have an activity entity that when the RT is doing something, we're logging, oh, they downloaded this report on this day, and then we use that for some other business functionality, but that's a log. We know that that person did something that day, it's visible to the end user. We sync with a lot of third-party billing companies for the payers and for device integrations. And we have a sync window entity that tracks the syncing of data for those systems, and that counts as logging. Once you have all this logging data, they're going to want to see that you have alerts set up for weird stuff that's happening at the system level, at the Drupal level, that you have intrusion detection set up, that you have scanning for anomalies. If you go with something like New Relic or Datadog, they have a lot of that built in. That's one of the reasons we went with Datadog. But you can certainly set some of that stuff up yourself if you have the right skill set to do it. The evidence we provided for this is access to our CloudTrail logs, our application logs, our retention policies that were set up in S3 and AWS Vault and the backups, and the alert configurations we had set up in AWS and Datadog. Next up is about user onboarding, when you're bringing not just users onto your application, but also employees into your company. When you're hiring employees or contractors, all of that needs to be tracked. Make sure you have a ticket type or something in your ticket system that says, we just hired this person, here's the checklist of everything we need to do. For that person, they need a laptop, they need to do this security training, they need to make sure they do this, they need to sign the handbook, they need to sign off that they've read our policies. It has to be a documented, repeatable process. The auditors want to see consistency. When you're doing access and account provisioning, all of that, again, needs to be documented. You can't, if you hire Bob, you can't just give Bob access to Google and the site because he was hired for that role. You need to have an Jira ticket or whatever ticket that says Bob was hired, this is on the checklist, he needs access to Google because he has this role, and it's been approved by the hiring manager, the CEO, the COO, whoever. And that applies to all of this stuff. Typical access, best practices, least access. Don't give everybody admin access. You don't need to give them, access to every single application. Using things like SSO helps out a lot here. We use Google, and based off of our role in Google, that helps dictate what we have allowed access to in other systems. If they don't need access to production, don't give them access to production. And then we do have a break the glass account. Our COO technically has access to absolutely everything across the system in a painful way to get to it, but in an emergency, if I get hit by a bus and my senior dev, we're all going to DrupalCon, if we're going out one night and the van explodes, our COO has the ability to get into every single GitHub account and Jenkins account and Jira account and all of that at the admin owner level. So you want to break a class account to be able to have that backup. There's going to be legal and compliance requirements for some of these security frameworks. So background checks if it's part of your policy, NDAs and confidentiality agreements. Auditors are going to want proof that if you said these are required, that they were completed and put into your central storage, Google Docs, whatever it is. A lot of these frameworks are going to require security training. Those cheesy videos from 1996 that don't pick up that USB stick and put it into your computer. They're dumb, but you got to do them, especially for the not technical people that you're hiring. They need to, they do need to know. Don't pick up a USB stick and stick it into your computer. How to handle, in our case, PHI properly, where you shouldn't be sharing it. What's the nice way to share it? How to detect social engineering and phishing scams. We get scammed. We don't get scammed. We get attempted to be scammed all the time. at our job. I get text messages from my CEO at least 3-4 times a month saying, hey, can you transfer money to this thing? Hey, I need you to deploy this thing over here. And haha, nice try, block. You have, as technical folks, we might know this, but other people, aren't really going to be able to check those and know to verify those things first. If they're using specific tools like Jira or Confluence or whatever, that's what we use, then you want to prove that they got training on those tools when they got hired. If they're giving devices, you just got to prove that this person was assigned that device. We have control over that device. We can lock that device down. They've been, they accepted the control over that device. Make sure that device is configured with endpoint protection and has good security baselines, disk encryption, and all of that jazz. You need to just prove that all of that was done. The evidence we keep for this is our onboarding tickets, the signed NDAs and policies, anytime access is granted, the tickets that did that, the logs that they completed trainings. Basically, all of that was involved. It's going to produce some form of log or deliverable document or someone in a ticket saying, this person did this thing, I can attest to that. That's the proof that we need. For offboarding, you do all of that in reverse. Disable accounts, revoke access, all of that jazz. Just do it all backwards. And keep that same evidence. You have all the tickets for creating a employee or contractor. You need a ticket to offboard them with that same checklist and that same proof that access was removed and how long it remained active after termination. So on the topic of access control, everybody does not need access to everything. Least privilege is the guide here. You want to enforce role-based access controls. It's just an easy way to make sure that the people in the specific roles have access to what they want. This applies not just for Drupal, but for AWS, for Jira, for all of the software that you're using that can touch production operations. This applies to that. Everything needs to have MFA enabled. And using SSO where possible, they like that because it's consistent, it's easy, it ties everything together. For us in Drupal, we're using, for our multi-tenant application, we use groups module to lock down access to the specific areas. All of that organization's content is in a single group and tied down that way. Admin accounts, this was an interesting one. We use Microsoft for our endpoint accounts for Windows. And I have my regular account that I log into my laptop with, but it has no admin access. I have a separate admin account if I need to do any elevated privileges on the Windows machines. The same thing I had to do for AWS. They want a separate account so that my day-to-day user can't just do admin stuff. If I have to do something elevated, I need to use a separate admin account, so that it is cleanly auditable in the logs that admin user Matthew was doing something here and regular user Matthew was doing stuff over here. For our apps and servers, again, you want to control the access into those. Our networks are denied default networking, and that was a requirement of HITRUST. None of our networks could just allow all incoming requests. So we set it up. It's all a private network, and we poke holes through it here and there as you need to, with the firewall and with the security groups and with the app layer firewall. The actual server access, the SSH, we're using Tailscale, is really great because it audits, logs everything. It's really easy to do the access controls there. My evidence for them was just a screenshot of the access control, and that says these are the people that are allowed to shell into these different environments. All of this and all of these changes need to be documented. When we made the decision to use Tailscale, instead of the AWS VPN, I had to create a ticket and say, we're going to do this. This is why. This is what's going to gain us. This is what it's going to cost us. And then I had to be approved by my COO, and then I could implement it. Google SSO in Tailscale, because that's how, if I want to show into a server, I SSH prod, I hit enter, a link shows up, I click the link, I sign into Tailscale with my Google account, and then that access policy says, yeah, he's allowed to show into that server, and proof I'm in the server. And Google's logging that, and Tailscale's logging that. If I have to offboard somebody and we disable a Google account, that just removes their access to a bunch of stuff. That's what makes SSO really helpful in this type of a situation. Network perimeter controls, use firewalls, only let things go through that should go through, or that you need to go through. Obviously, no plain text traffic, everything needs to be through TLS. Ideally, all of this you want in infrastructure as code, and we'll talk about that a little bit more later. We have a web application firewall. If you don't, you should. It just helps protect against the most common attacks that can come out there. If there's a new 0-day, the WAFs are usually the fastest to implement where they can. Fixes for it. So if you're just behind it, you just wait. We use AWS for our production environment. We use Cloudflare for our non-production environments. But everybody has one. Azure has it, Google has it, and then there's the independent ones out there as well. It's not a magic solution. You still need to have secure code and monitoring and least privileges behind it, but it's just another tool in the toolbox. All of this access is being dictated by your access control policy and procedures. So you need to review that very often. I think we review ours twice a year. And we're reviewing that the policies are still applicable, if we need to change anything, and then we review any access control changes that happened at the time, whether any new employees that were brought on board or off board. Did anybody get access to something? Did anyone lose access to something? The evidence provided was screenshots of all the above. And I may start skipping the evidence provided slides. The evidence is always going to be screenshots of your config, screenshots of your logs. Maybe they want a CSV dump of your logs or something like that. It's just screenshots of everything that shows that you did what you were supposed to do. All right, let's talk about the actual tickets. And we're going to have to start speeding up here. The SDLC, or the software development lifecycle, is a huge part of your compliance. This is another big chunk of those controls and requests that you have to prove, and it all starts with documentation. Everything you do has to be documented, and it has to start when someone says, hey, I think we should do this. The moment someone says, I think we should do this, and you're serious about it, open up a Jira ticket or a project ticket or Google Doc or something to start working on it. You have to show that you thought through the change you wanted to make to production. You have to provide the context and the background. Why did you want to do this? Why does the business need this? Is this going to affect any regulations or security requirements? What's the security impact? Is this going to affect confidential information? Is it going to affect the integrity of the platform, the availability of the platform? Are there any risks if we don't do this? Is it going to impact privacy? Does it involve PII or PHI? What's the minimum, what's the way we can reduce the minimum amount of data impact on this ticket? What regulatory impacts is this affecting? Do we have acceptance criteria for this? Are there dependencies and constraints on other systems? What systems, teams, vendors are going to be impacted by this? Are there any technical blockings or a sequence of events that we need to do for this one thing? That should we do this? You have to document all of that for that. That is where AI comes in handy, because I'll open up AI and say, all right, we're doing new requirements. My COO says he wants to do this. I'll put all my thoughts in there and hit enter, and then it will help me walk through all the different things that we haven't thought about. And I've told the AI that this is all the stuff that we have to account for. So That starts at the left side. On the right side, when it comes to actually, you do all that work, you have a release ready, and you're going to put that release live, you have to document that release. I want to push this live. We obviously, you might have a pull request into your prod or trunk branch. You might just be tagging it in GitHub after you merged a bunch of stuff there. That documents as, that counts as part of your documentation, but you need to show that someone approved that the individual things were allowed to go into that production branch, and then you have to show that somebody approved that production branch as a whole to go live at that time. So you still need a ticket for the release as a whole that says, this is ready to go live. Is this allowed to go live? Yes, it is. Okay, I'm pushing it live. A key part of this is the status change. Andy's my manager. I have a release ready. It's in my name. I assign it to him as release ready and say, this is ready to go. Click here to see everything that's in it. Is this approved to go live? And then he says, approved, and assigns back to me. The screenshot that we take is those status changes to show this was assigned to him, he approved it, it came back to me. Infrastructure changes, you want to document those. Every change to your servers that you make, if you're adding new ones, changing the configuration or software on it, you have to document that. I talked about use AI. It really helps because you're telling it everything that's required, and it helps make sure that you've covered all of those bases. An important part of this software development life cycle is the person who develops the code is not allowed to just go deploy that code. That's a hard one, especially for small teams. But that doesn't mean that the developer literally can't push it live. It just means I can't develop code and push it live without getting somebody else's approval. I need to say, all right, we need to do this work. I do the work. I create the PR. I want to merge it in. Let's say it passes code review, we merge it into the production branch. It can't go live until I say, hey, this is ready to go live. Do you approve this to go live? Somebody else has to have that status change to approve it. And once they assign it back to me with that approval, then it can go live. So you just need that separation of duties where one person can't go from start to finish the production without anybody else knowing about it. This could be a separate developer that does code review. It could be a product stakeholder that does UAT. It could be the developer manager that reviews the release before it's tagged and pushed live. You just need one other person in that mix to break up it. All right, QA and UAT mirrors production. They really care about if you have a QA environment or UAT environment, that the software versions, that it's as identical to production as you can. Same, MySQL version, same Nginx version, down to every little bit that's on there. So that was pretty important. It should be as identical as possible. We have all of our production stuff in AWS, spread out and across like you would expect. And then we have one server, that's our utility server, that we actually do VDev instances for our PRs, but the versions of our PHP and MySQL and Nginx match what's on production, so that helps. You want automated tests and security scans. That's Dependabot in GitHub, that's PHP Stand, PHP CS, server scans. All of those automated scanning tools you have to have on, you have to have enabled. If it finds something, you have to resolve it, especially anything that's critical or high. For HITRUST, this was interesting. They really wanted fully static deployments. They wanted us to build an artifact and archive it, and then release that archive to the production server. They don't want Git or build tools on the production server. They want it as clean as possible. We don't actually do that right now, but we're getting closer to it. But because of all the other security controls we have and how isolated our instances were, we were still able to pass the controls with a high enough score. Evidence was screenshots of everything. Configuration management. This is how you control and document your information architecture. If you're not doing it right now, start. Terraform, CloudFormation, we use SST. We originally used it for our front end and have started using it for our back end. Your entire infrastructure should be designed in code and deployed by your code, not manually going into a console and clicking, create new server with this image and do this, and then logging into the server and sudo apt install this. None of that should be happening. It should all be automated and in the code, except when you can. When I came onto this platform, it was a 7-year-old legacy infrastructure, and again, since it was all done manually and we had secured it so much, we still passed the controls for that infrastructure as long as all the new stuff we were doing were infrastructure as code. All of our DevOps is automated. Again, don't manually be pushing stuff live. Write a bash script, write a Ansible script, have Jenkins run it, have some other tooling run your deployments, run your spin-ups, run your anything that you would manually go into a server and run some commands. Ideally, you want to have that automated, because then it's in a repository, someone had to approve that change to get in there, and it's a repeatable, consistent process. Don't manually log into production and change things. Obviously hot fixes are going to be required. There's going to be an emergency and something's going to be broken and you have to hop on prompt, make that one change. But if you do that, you then immediately need to start following the SDLC, create that ticket and say, hey, we made this change, and backport it and still go through all that same process. Environment separation is a big one. You have to have prod here and staging over here. You really, you shouldn't have it all in the same place. Don't share credentials and roles. Account level boundaries is really important, because, if God forbid something does get, your staging gets, jeopardized, it means that they can't take that and hop into your production. For us, AWS organizations have the ability to create separate accounts under one organization, and that helps out a lot. And every other major platform out there has that. Let's see, we're going to start skipping a few slides. If you're not on AWS, like I said, Azure has management groups and subscriptions. Google has organizations and folders and projects. You can still do that. Another quick one is all of your resources, whether it's your laptops, whether it's your servers in the cloud. They want everything tagged with what it is, what its purpose is. Does it have PHI? Who owns it? Who's the contact for it? So use tags and labels. This is just an example of one of our servers. You just have to define, for us, the security level, whether it had the private information on it or not. Just make sure everything's tagged. And when you're doing infrastructure as code, that's really easy. Everything needs to be encrypted across the board. Encrypt your databases at rest, file storage, backups, everything in transit should be SSL. Document encryption standards in your policy. Make sure you have key management for your secrets. Obviously, don't commit your secrets to version control. Have some sort of solution for how those are being secured. Even if you think something might have happened, rotate the key. All the systems have ways to manage secrets. We use AWS Secret Manager. There's Ansible Vault. There's, we use 1Password. There's lots of different ways to keep your secrets secret. Backups are a very big one for security policies, security frameworks. You have to have this defined at a core frequency. They have to be protected by access controls. So, your user may have access to shell to the production server, but that doesn't mean they need access to the production backups. They have to be immutable. They have to be, the retention periods need to be defined and enforced in your policy. Some of that is just what you want to do. Some of that will be determined by the security framework itself. And then you need to test those backups regularly. The auditors want to see that you've documented it all, that you have the schedule configured and running, and that you have tested restoring those backups. We keep anything production related backed up, the database, the files, images, all the volumes on prod. Obviously all the code is backed up through Git. So our configuration infrastructure code is backed up there. All of your encryption keys and secrets, we have those backed up as well. And then our logs also get backed up in S3 in Vault and cold storage as well. And then any critical third-party SaaS data, if you're using another party service that's critical to your operations, what happens if they go down or you can't get access to that anymore? You need to account for that. Retention policies just depend on what framework you're going for. And we've already talked about that. So RPO versus RTO, how much, let's say, something catastrophic happened, US East 1 got nuked, and all your data there is lost. How much data can you afford to lose? And how much time do you need to recover that in before it becomes a critical issue? So these two items need to be documented, and you need to test that you can actually do those point in times. You can afford to lose 1 hour's worth of data, and you have to get the system back online in 4 hours. And you have to test it. If you don't test your data recovery or disaster recovery, then you don't have disaster recovery. If you don't test your backups, you don't have backups. Test the full restore the database that you have access to it. Obviously I can't test a complete production rebuild without causing an issue, but what I can test is restoring the production database and accessing that from a temporary prod instance that nobody's going to say, yep, everything is there, everything's supposed to do what it's doing. Test that you can that you're not losing greater than your RPO time, or that you can get it restored within your RTO time. And you have to test it at least annually. I think right now we're testing it annually, but we really should test it more often. Some backups, audit gaps is you're not doing some of the stuff I just said. So incident response. This is part of the whole disaster recovery and business continuity plans. What happens if my CEO gets hit by a bus? What happens if the COO gets hit by a bus? What do we do? You have to document out everybody that's in those roles, what their responsibilities are, and then have a plan for what happens if you can't, that person is gone. So during an incident, they want to see that you are assigning it to somebody to handle the incident. You're following the procedure that you've dictated. You've logged everything that was happening. This could be a disaster recovery. It could be an outage. It could be, whatever. And then after the incident, they want to see that you had a review, that you found out what the cause was. You can't just say, we'll do better next time, without assigning specific actions. If something goes down on prod because of some reason, resolve it, but then document why did that happen, assign it to someone, make sure you get it fixed. And then you need to, test that ahead of time. We have disaster recovery testing where we, just get on the Slack for a Google Meet, and say, okay, someone got hit by a bus. What do we have to do when the server's down? And we go through the procedure. I know we're over time. We will get through this really quick. If you're using one of the major platforms, you don't have to do all of the controls. You can inherit a lot of the controls. I don't have to, prove that the data center has locks on the doors. AWS has to do that. They've already proven it. They have a report. I can show them the auditors that we're with AWS. They have already proven that. Here's their report. So inherit from them, and you're good to go. You need to do penetration testing. Do it at least once a year. What we do for ours is kind of like if you have someone who's coming to clean your house, you're going to clean it up first, and do the same thing. Run your own penetration test internally. Get rid of the low-hanging fruit. Obviously, get rid of anything critical or high on the list, and then let them do it. Here are some tools that I use for our security tests, and then it's pretty straightforward. You tell them here's the endpoints, the APIs that you're going to be testing. We set up some user roles for them. And then they do it. And whatever they find, you just got to make sure you resolve anything that is critical or high, and you're good to go. Asset tracking is make sure you're tracking your laptops. That, again, could be as simple as a spreadsheet, or you can use an actual tool. Now let's talk about some really quick Drupal things, and I'll make sure these slides are all available to you guys. This is my 1-hour version. I meant to cut it down. Treat Drupal as a framework. It's not just a CMS. It's a whole platform that you need to secure as a whole. Obviously, use config management, all the stuff we've talked about. Don't edit things directly on production. Check your roles and permissions. Here are some modules. Slides will be available, but there's lots of helpful things when it comes to authentication and identity. Lots of helpful modules for access control. Like I said, we use groups. You can have role delegation, permissions by entity, content access. Drupal core has a great permissions access API. Now, hardened and security defaults we've used to help to make sure that you have some security defaults set up when it comes to headers and stuff. Paranoia is a good one. It disables the PHP visibility block, creating import filters with the PHP filter, it disables the user one account, prevents granting risky permissions. So that's a pretty neat one. Protect your forms and other forms of input. Anti-bot and auto-ban will, block users or accounts that are trying to spam you. Log everything. We use monologue, and it's pretty great. We're pushing stuff to open search. Your config chain. When configuration changes happen, you need to track updates of that. We get notifications when config changes happen during deployments. When someone were to manually go in and change config for some reason, that'll get notified. API security, rate limiters, OAuth, JWT tokens, field encryption. If you have to store sensitive information in your content, you can encrypt that data pretty easily. This is some DevOps and code quality stuff, but static analysis, all of those tools that make sure your code is good. Dependabot to make sure that all your dependencies are good, or whatever system you're using has something similar. Make sure that your CI/CD pipeline has a QA stage, a UAT stage, automated testing if you can do it. Protect your PHI. For multi-tenant, like I said, we're using groups. We have per entity access handlers that essentially enforce row-level security. And with all the context we're putting into our logs, we have almost row-level security of our logs as well, because we know each account, organization, region, facility, patient for any given log where that's applicable. Our non-prod database is complete. Our database is enormous. It's like 120 gigabytes. So we can't just sanitize that. So we have a separate database that is just prod without all the data on it, and then we generate a bunch of dummy data. But if your database is able to be sanitized, then use the sanitizing tools. Evidence you can gather, screenshots of all the above. We already know that one, I did that one. Yeah, all right, so closing, takeaways. Sorry, a lot of slides. Number one thing, what's the number one thing for security?
It's logging.
Document everything. Document continuously, always.
And change management in that documentation.
Document everything. Integrate this into your daily workflow. Just get into a habit of, if anything needs to happen, create a ticket for it, and then do it, and then close it. It doesn't matter if your ticket IDs are in the 10,000s. You can't under-document when it comes to security. Know what's in scope and what's out of scope. Use your inheritance. Treat compliance like engineering. Automate as much of it as possible. The last thing I'm trying to do is figure out how to automate the screenshot part of it. It's not enough to just, you can't just go take a screenshot. You have to take a screenshot that shows a clock, that shows the date and time of that. And I'm actually just I realized I've never got video of myself, so I'm just gonna do a little clip of myself here. if this turns on. Oh, the battery died. Oh well. You can't just take a screenshot of your security policy. You have to take a screenshot that includes some form of clock that shows the date and time that you took that screenshot to prove that it happened at that time. So that's something I'm looking to automate. And then, again, document everything. That's the most important thing. Because there were a lot of times they said, well, can you prove this? Can you prove that? And we said, well, we totally did that, but I can't prove that we did that because nobody wrote it down. Yeah, and if it's not clear, document anything. Thank you guys for letting me go over. If you have any questions, I can happily stick around and answer them. We can talk later. I will have these slides available to everybody. Thank you for coming to my TED Talk.